Taking a look at each of the cylinders, each of the cylinders has a volume of 1,884 inches cubed. We want to find the missing dimensions. So for the first cylinder, the height is missing. For the second cylinder, the radius is missing. So for the first cylinder, what is the measurement for the height going to be? Eker? 24. And then for the second cylinder, what is the radius going to be equal to, Caleb? 10. Okay, so let's go over that. Again, be mindful of these. These are very common test questions, so you want to make sure you're paying very close attention to this. For the very first problem, again, you need to know the area of your base shape. When we're talking about volume, like we learned yesterday, volume is equal to the area of our base shape, which was that capital B, multiplied by the height of the prism, which connects your two base shapes together. Okay, so that capital H. Bring me your device. What we're going to do here, because we're dealing with cylinders, we know that the volume, we know the volume is found by doing radius squared times the pi, and then because that's the area formula for our circle, and then we're going to multiply it by the overall height. Okay, now the overall height is the value that is missing. What we do have given to us here is the diameter. They told us that the diameter is going to be equal to 10, but remember, we don't want diameter, we want the radius. So if the diameter is equal to 10, then that means the radius is equal to what? 5, right? Half of the diameter. Okay, so we can fill in the information that we are told. We know what the volume is, that it's 1,884. So we can replace the volume with 1,884. We can place the R with 5. So we have 5 squared. We can replace pi with 3.14. And then, of course, we don't know what H is. So H is going to remain blank. Okay, when we do 3.14 times 5 squared, that's going to become 78.5. Stop talking. So we have 78.5 H for this side, and then of course the 1,884 for the other side. In order for us to be able to get H by itself, all you have to do is just divide both sides by that 78.5. Okay, it's setting it up and solving it like an equation. So we would find that the value of H is 24. Okay, with the second cylinder, the R value that is missing, again, setting it up the same idea, that our volume is at 1,884. We do not know what R is this time, so it's just going to remain as R squared, and we're going to multiply it by 3.14, and then we're going to multiply by the height that we do happen to know, which in this case is that 6. Okay, so we can multiply the values that we do happen to know, which is 3.14 and that 6. When we multiply these together, that's going to give us 18.84. Okay, and we still have that R squared that gets multiplied to it, and the whole thing is still set equal to 1,884. So dividing, if we go ahead and just divide both sides by 18.84, then we're going to get that R squared is equal to 100. Okay, R squared is going to be equal to 100. Now, one of the things that you need to make sure you understand, that's not the value of R, that's just the value of what R squared is. So whenever you have an exponent, you do have inverse operations to exponents. You know that the inverse of multiplication is division. You know that the inverse of addition is subtraction. But there also is an inverse of your exponent. So the inverse operation of x squared is to take the square root. So if you want to undo an exponent, you use a root to undo it. And that's for every exponent. So the inverse of a squared exponent is a square root. Stop talking to each other. The inverse of a cubed exponent is called a cubed root. You take a cubed root of the value. Inverse of a fourth power you take a fourth root. So whatever your exponent is, you have a root that is the inverse operation to it. Okay, so all we would be doing here is taking the square root of both sides in order for us to get r by itself. So r would be equal to 10. That's going to be a very important understanding when we get into Pythagorean theorem, which is the last thing that we will be doing with geometry, but we won't be doing it until after milestones because it's not on your milestones. So we'll wait until milestones is over, and then you'll get into Pythagorean theorem and the distance formula, which uses roots, inverse operations as roots heavily. So you want to make sure that you remember that the inverse of an exponent is a root. All right, so the last thing that we're going to be learning about for this portion of our geometry unit and your test on Friday, we're going to be going over cones and spheres. The formula for cones and spheres. Okay, so volume of a cone. When we talk about the volume of a cone, we have the formula volume is equal to 1/3 pi r squared times the height. Okay, the reason that it's 1/3 is because if you're looking at the pi r squared times height formula, that's your cylinder formula right there. Pi r squared times height, that's your cylinder. When we take 1/3 of it, that gives us a cone. And the reason for that is because if you take a cylinder and a cone, and they have the exact same radius and they have the exact same height, but just one of them is a cylinder and one's a cone, then if you fill that cone up with water 3 times and pour it into the cylinder, it'll fit perfectly into the cylinder. Okay, so a cone is just 1/3 of a cylinder's volume. If they are the exact same measurements, same radius, same height, when those are exactly the same, then 3 cones can fit inside of 1 cylinder. Okay, so for a problem like here, what we have on our example, we have a height that is equal to 8, and we happen to have a radius that is equal to 5. So when we're plugging this into our formula, volume is equal to 1/3, and then we're going to do the area formula for the circle. So 5 squared times 3.14, and then we're going to multiply that by the height. Multiply it by 8. You're just substituting it all into your formula. Volumes of cones are 1/3 of the volume that you would normally do for a cylinder. That's all. And then you're just going to multiply. Okay? So in this situation, we do have a repeated decimal. So it does come out to 209.3 repeated. So we're just going to put the repeat symbol on top. When they are doing problems, they'll typically tell you to round it to like the 10th or to the 100th or whatever value that you're rounding to. Kaden, are you writing this down, or are you still fixated on the fact that I took your phone? Okay, All right, volume of spheres. For volume of spheres, we have the formula 4/3 times pi r cubed. So there is no such thing as a height of a sphere. Okay, there's no such thing as a height of a sphere, so the only thing that you have to worry about is the radius of the sphere. So you substitute it into your formula. So in this case, we have a diameter that is equal to 6. So what is the radius equal to? 3. And then we substitute it into the formula. So we have volume is equal to 4/3 times pi, which is 3.14, times the radius, 3, raised to the 3rd power. The reason it's raised to the 3rd power is because you don't just have your measurements going left and right or up and down, but you've got that measurement that's coming out as well. Okay, so it's that 3-dimensional measurement. All right. When we multiply all of those together, then you get your volume. So in this case, the volume is going to be equal to 113.04. And that is meters cubed. Okay. So now keeping those in mind, with our formulas that we have here, if I were to give you a hemisphere, then all you would have to do is take the volume formula and then divide it by what? 2, right? If you have a semicircle or a hemisphere, you would take the volume of your sphere and then divide it by 2 at the very end of that. These are some composite figures that we have going on here. So for problem number 1 all the way through problem 5, we've got a whole bunch of different composite figures. So that means that you are combining different volumes together, finding the volume of this cone and the volume of the sphere or hemisphere and combining those together. So you're going to work with your table mates for today, and then I will present to you what the answers are, the solutions are at the end of class. But you are going through each problem with your table mates. Go ahead and begin.